I would like to introduce Helge, who is talking about their company and their issues on Google Cloud, Market Logic Software. So the stage is yours, Helge. Switching over.
Okay, let's see if that is working. So that looks very laggy on YouTube, but I will give it a try. So we didn't have any GCP issues, just as a pre-hint, but let's just start with the presentation, right? So I'm Helge Rennicke. I'm Director of Software Development at Market Logic and working here for about 6 years. And what we are doing at the company, so we are, let's say, I'll just give an example. So if you just go into your kitchen or into your bathroom, just open any shelf and then you will see different products there and just grab one out of it and just take a look on who was developing it or who is providing it. You will see companies also which are located here on the screen. So you will see L'Oreal, you will see Kellogg's, Coca-Cola, you will see Mars, Procter & Gamble products, for example. And the question is, how do these companies are going to innovate these kind of products? Because this can become quite expensive to know what the customers really want to have, what they, how the packaging should look like, where it should be located at storages and so on. And for, let's say, digital people like we are, it's quite easy because, say, you have innovation just out of the blue. You just put one developer on a computer and start programming. You have innovation, right? So, but for these kind of companies, innovation can become very expensive, large scale, and also very delaying. And what our company and software is doing, we are supporting them in this innovation process. But as this is a tech call here, let's talk about technical stuff, right? And I also don't want to talk about the fancy new features we are using on GCP. I want to talk about how our innovation path looked like on a technical perspective. For that, I will go back in time. And let's say 5 years back, starting with 2015, and showing you, hey, we had a very big monolith as an application, and how we were going between the years, changing different topics and stuff to become a scalable Kubernetes infrastructure landscape and multi-tenant architecture. So let's start with the super old stuff. It sounds very funny when I start talking about it because it's unbelievable that we ever had it. I will not go into details of every point here, but just to have a rough overview what environment we had. So for example, here we had 150 single bare metal nodes, which needs to be maintained and also updated and with different tenants on it, yeah. And we also had mixed Linux Windows installation, which is also a very interesting landscape and gives different issues on deploying the software. And to make it even more complex, we had also on-premise installations. And this can become super difficult if you don't have the right infrastructure and people who are doing it. From the application point of view, this was, I have to say it was, it's not is anymore, but was a three-tier architecture, right? So you have a database under the hood, a JBoss 4.2, which was quite outdated at that time already, and GWT, Google Web Toolkit, if you don't know these 3 letters, application in front of it. So sounds easy, hey, it's just 3 tiers, right? So who cares, easy. But if you just open now how big the application was, so we had 20 million lines of Java code. Yeah, we had a Snowflake database model with thousands of tables. And if you just imagine what that means on a SQL statement level, you can imagine that if you do join, 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 union, left, right, this is an quite interesting part. So to make it more, let's say, not bad, worse, however it is, depends on if you having issues with it or not, is at that time we had no standardized build tool also. So we were just creating custom ARM script. I think just the ARM script were more than 100 or 200,000 lines. and we are doing a cron tab based build. So every 1 hour, every 10 hours, every week, we are doing the builds, right? No Nexus. No. Also the version numbering. I don't think I will ever talk again in my life about how a version number should look like for artifacts. Of course, nowadays it's major, minor, micro, and some kind of prefix. And also 6 hours downtime for a deployment, for a single deployment, is not what you would call CI/CD nowadays. And also the turnaround times for developers with about 1 hour for a single commit is far too much. And this is where we are coming from. So I think it can maybe not be more worse, but interesting to have it. Then the question was, hey, how we can get out of this, how we can split it, and how we can make the turnaround times for the developers even better. Yeah? So it was at that time even hard to hire people because no one was knowing anything about GWT. And if they were looking peak look into the software, they were already understanding that this is a dead end system. So at that point, we were eliminating the Windows environment and everything was on Linux. And we were starting to split off these 20 million line application into several parts. We were introducing React JavaScript as a fat var on the Tomcat level. And we were also introducing Spring Boot 1.3 into it. And this was incredibly increasing the amount of turnaround times. Drawback of the Spring Boot topic is that we don't had web services before. Then we had web services, but these Spring Boots were needing to connect to the JBoss via RMI protocol. And I don't think you will have any luck with Google to find any useful documentation how to connect Spring Boot to RMI connector of the JBoss. But in the end, it worked. We were changing also this ARM style build to a Gradle build because the Maven one was too strict. We were not able to make that in time, but the Gradle one is more like, has more scripting support. So this was a more useful way to go. We were introducing Nexus. We were introducing the first automated test in our company. And still we had a lot of manual testing also. We introduced Maven style versioning, and maybe the most important and undervalued point, we introduced Google code formatting of the Java code. I have no idea how long I was discussing with developers what is the right style of formatting the Java code, if the curly bracket should be at the end or at the beginning. Should you have intent of 2, 3, 4 with tabs, without tabs, with spaces? And the difference between the IntelliJ and Eclipse formatting is small, but the version system on commit and merges don't like that at all. So the Google formatting was helping us here. And also we were introducing a pre-commit hook, which was checking if the code formatting was even applied and refusing the commit. That was most major step in our company history, I think. And last but not least, we were also introducing a tailored template. This is some kind of layouting of how a development project for a component should look like. So that's that you're using Gradle, that you're using the directories in that structure, how the structures inside, how tests are made, how integration tests are made, that we're using APIs and so on. So this gives some kind of blueprinting style to the developer and to not have too many creativity. This can sometimes be good and sometimes be not. Let's say it like this. Okay, 2017. Right, so now we had several small pieces of Spring Boots. And then was the question, yeah, how we can make it more scalable, how we can do failovers, how we can bring that to our customers, and how we can make sure that this hundreds of Spring Boots, which we might have in future, is not overkilling the resource requests we have, right? So we still had these bare metal single nodes for each tenant. We were introducing Docker at the first place. And we also introduced the first time Kubernetes on a 1.4 installation. But if I remember back correctly, at that time you had only local disk and no remote PVCs, and you had no cron jobs inside the K8, and that's quite funny. At that time, we also introduced Grafana and Prometheus as monitoring because we noted quite fast that as more components you have, as more complex it will be to analyze any kind of application issues. Yeah, so if you have strange random system behavior, who's the root cause, how to find it. So you will need insights of the monitoring in any case of that. Yeah. So I said we introduced Docker on all cases and also migrated all of the stuff from these Tomcat-based deploy to Docker-based deploy. So we turned around the way how it is made. And at that time, nowadays it sounds super weird, but at that time we were discussing about how we can orchestrate all these kind of Dockers, right? So at that time, you had just 1, 2, 3, 4, 10 Dockers maybe on your machine. And we were asking, yeah, but how you can synchronize them, how you can manage them, how you can update them even. And we were looking into different options how we can do it. And K8 was only one part of it. I think for some time we even had the idea to make our own orchestration framework with Ansible, and we also started to do that. But for lucky reasons, we were not continuing on it. Positive effect of all of these kind of splitting is that the microservices were supporting heavily the splitting of responsibility. So who is owning and who is responsible for doing something if you need a new feature, if you have a buggy feature and need to do something about it. Yeah. So then was right here, there's a problem in that component. That's why it's your issue. Do it. And also the messaging question was at that time very valid, and we decided for Kafka in favor of Rabbit and ActiveMQ. But this also has then some impact on the application logic. However, 1 year later, we were having everything on Kubernetes, so there was no application anymore running, or the current development at least was not running on any other environment anymore. We were also having shared nodes for the environment, and you see here Kubernetes bare metal with 50 nodes. It was already 750 CPUs, 6 terabyte of RAM. We did manual upgrades of the Kubernetes. I don't want to remember that, but we did it. So from 1.4 to 1.8, from 8 to 10 and to 12. We were using the Rook and Ceph file system, which is very interesting. So if you want to do something like this is something you should look into. We also had this change between kubespray and kubeadm, most difficult change we had on our end, I think. But we introduced something which is auto DNS registration for ingress. So that's quite interesting. Currently, if you are creating an ingress, it's assigning the cluster IP to the ingress, but the DNS name is not registered. So this is something we automated, and this is the reduced amount of manual work for our operation and SOE people heavily. I have to point out this part here with the ELK stack. So if you have so many different services, and the strategy before was log to local file, the strategy is not valid anymore. So you need to have some kind of distributed logging, and Elasticsearch Kibana stack was fitting that quite well, but it was overloaded. So we can, for our end, we cannot use the standard one because it's instantly overloaded with the amount of logs going. Same goes for Grafana and Prometheus. So just imagine, at that time we had 50 gigabytes of metric data scraped per 30 seconds. So you can imagine what that means on the disk. On the architecture level, we changed now at this here fully from this 3-tier architecture to the server mesh. We tried to prevent it and make it like a tree, but we failed. So now it's like a mesh. Everyone is calling everywhere, more or less. I have to say. But something which is super important we introduced was we introduced not just Spring Boot backend microservices, but we also introduced micro frontends. Yeah, so that means that you have not this fat var React packaging anymore, but you have per team, per use case, per component, you have some kind of UI you can deploy independently from the rest of the application. So that means you can deploy a full use case without interfering anyone else. What else we were using? Helm. Yeah, it's quite standard today. At that time, not. I think we were also making some bug fixes on Helm. We were also using Helm's Man in favor of Helm Umbrella because we were screwing the Helm Umbrella deployment simply because of the size of the YAML file. So the YAML file was that large that the Helm Umbrella was not able to transfer it anymore to the tiller pod on the Kubernetes cluster. And finally, we were going live with that application in a big meeting in a cinema, and everyone was super happy that this was working out finally, and it was a big party, and I like to remember that. Some learnings we took out of that year is do not overcommit on pod memory, bad idea, otherwise you will have OOM killed from the kernel level. And telepresence, this can port forward your local machine into the cluster and let's use the services there, has some advantages and some disadvantages. If you develop, it's cool. If you do it on production, it's a bad idea. Make sure that your overlay network is monitored, because at that time also we were encountering this massive increasing of nodes that limits the default limits of the Kubernetes and the default limits of the overlay network was reaching the limit. So you have to tweak it, and you need to know what you're doing there. Otherwise, it will start to react very strange. And we were introducing fortified Docker containers. That means that you have read-only containers, and everything else inside that Alpine or Debian or Ubuntu image is more or less deleted. And that's super important when you want to secure your environment. And last but not least, Rancher, we were introducing to limit the developers from accessing our clusters, because at that time, you were only able to give people access to the Kubernetes, but not revoke it. As you had to give the certificate file out, you could use it at any time, but you could not say if you were offboarding people or wanted to limit the access for a guy, that this can be revoked. So we introduced Rancher not to deploy and maintain our clusters, just to link our Active Directory with the Kubernetes access. Yeah? And then we had the idea that with this bare metal, the number of incidents we had with the bare metal was increasing. So we had to take care of disk changes, network adapter faulty, and also just buying new hardware was taking a week. So it could not react instantly on the issues we had. And we were having at that time the idea, hey, we can go to a cloud provider, right? So we were switching not to Google, but to a cloud provider. And I think that's why we had a year of disasters. On this cloud provider, I think we encountered more or less everything what's possible. So main issue here was that the nodes got time desynced. Yeah, so that means that node 1 is more than 5 minutes out of range of another node. So we had to introduce our own time synchronization. We had to suffer PVC remounting issues. So that means if your Kafka 5-node, if you have a 5-node Kafka or Zookeeper or Postgres, Elastic, whatever it is, with a stateful disk, then you are killing a node, or you want to drain a node, or you want to shift that pod to another node, the disk needs to be remounted to that new node, right? So, and this was not working. So a remounting of a single disk was taking up to 30 minutes, 30 minutes. Yeah, so for a 5-instance Kafka, you were needing 30 minutes multiplied by 5 because it was also serialized. And even to make it even more worse, we were hitting the cloud provider hard-coded quota limit inside the Kube API. So that means that the pod scheduler, for example, could not schedule any more pods. So the daemon sets were failing. You could not deploy a normal daemon set anymore because he could not deploy, he could not react to that change. And in the end, we were writing a synthetic test so you could spawn a vanilla Kubernetes cluster, just deploy that synthetic test to it, and was instantly crashing in that way that not even the expert support from that cloud provider could save that cluster from the fail state. In the end, we were hiring external consultants. We were also discussing with the developers directly who was from that cloud provider developing that feature for this guy. And I think if you take a look on the 1.14 and 1.15 changelogs of Kubernetes, all of the issues you find there regarding PVCs or disks are our issues. Okay, but anyway, 2020, in the end of 2019, I convinced then our C-level to make a change from this cloud provider to another one. So we were switching all of our environments within about 3 days to Google Kubernetes. So I was just going to the CTO and saying, hey, I need a credit card. And he was saying, hey, why you need my credit card? And he was already scared, and that was right that he was scared. So we were just buying as many nodes as we could, and I think that was stretching the approval process even within Google up to the limits. But in the end, we had about 100 nodes, 1,500 CPUs, 12 terabyte of RAM. That was one cluster out of 5. We were migrating. And so we have about 600 pods running in environment. We have Kubernetes 16 and 17 now running. And we are using Velero for snapshotting the backups. We now finally have Let's Encrypt, auto certification creation, auto DNS registration, and also status cake. That's you have external tests running. And we are experimenting right now with WAF and CloudNut. We still have the Grafana Prometheus stack. And right now, more than 100 Spring Boot microservices in one environment, also more than 50 micro front ends. And oh, there's one slide missing. Let's see if I can scroll down here. Yeah. So most boring part is there was no disaster. So everyone was just waiting. Hey, when the next bad thing will happen? And nothing happened. So what we had to do in this year was we had to do a DRP, disaster recovery training, to to fulfill our requirements from the auditors, because there was no disaster in that year. So we had to do it on our own. Learnings from that year is you should not use rapid channel in Google Kubernetes. Then some other presenter here was already saying, hey, fun with preemptive nodes. I can totally agree with him. If you're going for preemptive nodes, you should be aware of that there is lots of pod terminations because the nodes are fading away often. And there seems to be a state missing in between running and terminating, where the SVC HTTP routing is still going to that pod. You need to be aware of that you use post the pre-stop here carefully. If you have something like Java Spring Boot running, you should be aware that it needs to support shutdown, graceful shutdown fully. And also affinity and anti-affinity is your friend. It sounds easy, but it's easy to forget. And Containerd versus Dockerd is a quite cool performance improvement without any impact. So we are running all of our clusters in Containerd, and that's working super nice. So 2021, the question is what to do now, right? So as everything is working, we need to find something new to work on. What we are currently looking into is, of course, more innovation, and we are interested in these serverless services. Or different topic would be GKE scale down to zero. That would be possible with custom metrics on the HPA. Then we are doing a Google Vision integration right now. Upcoming data plane changes would be potentially interesting, and training sounds easy, but it's not, as we are advancing quite fast in the technology. Also, we have to care now for the that our people are even getting behind or on board or up to date. It's quite hard right now to make that happen. And also something very interesting, what was just released is native snapshots are now available, and I really like it. And last but not least, before I come to the question part, I would have to say code formatting enforcement for the win. Yeah, don't miss to check out Rancher. Then I have a question to the community: why there is a node pod limit of 110? No one could answer that question to me in the last years. I would propose taking a look on cube cost for the component cost transparency and have fun with tracing. And now I'm open for any questions coming up.
Okay, thank you very much, Helge. We're waiting for the delay here. I'm writing. Are there any questions? Maybe people are already tired and hungry for the ones that did not get pizza.
I would like to have also pizza.
It's Switzerland only, sorry. Maybe I can get one. Okay, Helge had a question to you guys. Maybe Silvana can answer that question in the chat. Why is this limit of 110? What was it?
110 pods per node. Why we have this limit? I could not find any Kubernetes expert who could give a useful answer to that question.
Okay, I think there must be someone from Google, or should answer someone from Google. Maybe they don't know. Or the guys that know it, they don't talk to the customers. I'm not sure.
Anyway, I'm using this chance here.
Okay, so no reaction from the audience until now. We have still 23 people in the chat, or in the stream. Florent says thank you. So if there aren't any more questions or comments, I really like the talk. Never heard a talk of hitting so many limits and so many switches of providers. I'm sorry for the wrong introduction. Seems like Google is the best choice for you.
At least it was saving my life in the last year. And as I now don't need to react on disasters anymore, I can go through the innovation path.
Cool. Okay. Yeah, so I would like to thank you very much to Helge, and thanks for waiting, everyone, and thanks for inconvenience. So I say bye to Helge. It was nice to have you here. Thank you.
Thank you very much. It was nice to be here, and hope to see you soon.
Thanks.